Okay. Yes. So thank you for the question, Timothy. So the last time, yes, I said you could create all the functions and put it in one file, or you could put it in a few files. Okay. They don't all have to be in the same file. It can be in separate files. So let me try to do an example where I create different ones and I put them in different different files, and then I'll put them in two different files, and then I'll import the files, and then we'll see what happens. So I think you can see my screen. So now I go to Anaconda, but I go straight to Jupyter Notebook. I don't go through Anaconda Navigator again. I think you just need to do that the first time, or if you're using a new package from Anaconda Navigator. But I've used Jupyter Notebook several times. So I just go to Jupyter Notebook and then I'll wait. So it opens this window for me. So this will take some time because it will do some processes. And then finally it will give me my prompt in the browser. Okay, so waiting is going to give me what I need. Okay, so I'm going to create two module files. Oh, yeah. And one of them will have two functions, another will have one function. And then I'll be able to call those functions. Okay, so let me do this. I'll create a new file and I'll give it one, P1. Let me do this. So if and I'll create another one. I'll now move it to P1. Okay. So let me first open my module one and I'll type something in it. So I double click it. I'll define two things in it. Okay, so I'll define my cube. It will take X and it will return the cube of it. Okay, and then I'll define another one. Let's define my quad. Okay. So this will just return extra stuff for. Okay, so I save that. So I have that one there. So if I like, I can remove it. So this is in module one. And then I can do something for module two. Module two, I'll just put something that squares the function. Def minus cube square x. It just returns x plus 32. Okay. This is just for illustrative, sorry. For illustrative purposes. It's, okay. So now let me open a new Python file. Okay, so I open a new Python file. I think I did, yeah. So I'm opening a new Python file now. And what I'm going to do now is I'm going to try to just call the function without importing them. I will see what happens. Okay. Let me rename this. Today is April 25. Okay. So if I just say print my square 3.0, okay. I put shift enter. You see, it tells me it doesn't know what my square is. My square is not defined. Okay, so it's not defined. So what should I do? I should import the module. Import my module 1. Sorry, my module 2. That's where the square is, as M2. So let's just import it as M2. Okay. And then I can do M2 dot my square, and I can do this. Yeah, so you see it gives me 9 because now it has seen the module. If you now do print, I don't know. If you do print my cube 3.0, I'm going to get an error also because it doesn't know what my cube is. My cube is not in M2. So if you do M2 dot my cube, my module 2 has no attribute my cube, so it's not going to, it's going to give you this errors. So I have to import module 2 as M2, and then I can import my module 1 as M1. Okay, and then I can do M1.cube. So it prints 9, it prints 27. If you like, you can import everything that is in module 1. And then if you do that, you have to be careful with this. If you do that, then you'll be able to just use my cube and my quad. Okay, so let's do the same thing, but now, oh, actually, okay, so you don't have to do everything the same. Okay, so I can import and do nothing. Okay, and then after that, I can print M1 my cube. I can print M1 my quad 3.0. Okay. And it prints 92781. Okay. My quad is too powerful. Okay, so you can do that. Another thing you can do is you can just say from my module 1, import everything, start. Okay. And then you do shift enter. So it has imported everything. And then in that case, every module in every function in my module 1, you can call it and you can use it. Like I say, print my cube. Let's say 4.0. You see, I don't have to put M1 dot my cube again because I've imported everything. So if I do this, it prints my cube. But the problem with this is that, let's say you have 2 people that wrote my cube for you. Okay. One put it in my module 1, one put it in my module 2. So when you call it, how will it know which one to use? Okay. So it's going to use one of them anyway. Okay. Let's assume one of them is wrong. It's going to use one of them anyway. I actually don't know exactly how it will decide which one to use if you imported both of them like this. Okay. The problem with this that I'm going to illustrate to you is that when you do this and you print my cube, you don't know where it's taking my cube from. Okay. In the case where I have 2 functions that have my cube, let me give you an illustration. So in NumPy, there's exponential, or there's sign, and in maths there's sign. So if you do import from NumPy import star, okay, and if you also do from from maths import star, okay, then if you call a function like exponential 3.0, okay, then I don't know whether it's coming from maths or it's coming from NumPy, because both of them have exponential function. One way I can try to know is if I do, because now I know that the exponential function in NumPy can work vectorially. So if you have a vector, I don't even know. Let's see if this will work. So let's do 0, 1. That's this one. NumPy is not defined. So I actually want an array. Yeah, I imported the whole of NumPy, but let's do this. A equals array. Okay. So these are the NumPy array. And if I tell you to print the type for me. Yeah, it's a NumPy array. Okay, because there's this array function in NumPy. Now, if I tell you to find the exponential, for NumPy, you can find the exponential of an array. For maths, you cannot find the exponential of an array. Okay. So in this case now, because I cannot find the exponential, then I know it's using the exponential from NumPy. Sorry, from maths. Okay. But the main thing is that if you have two functions that have the same name in the different modules, if you import like this, you won't be able to tell from which module this function is coming from. Okay. But if you do something like this, like if you do something like this, import math as empty, and if you do import NumPy as np, then when I call it, I will know. So if I do print np dot exponential of a, okay, so I know exactly what I'm calling. That I'm calling the one from NumPy. Okay, so I'm not calling the one from maths. Okay, the one from NumPy can work on vector arrays. So remember our vector a. Let's print a first. Has two components. One is 0 and one is 1. So this one is exponential 0, and this 2.718 is exponential 1. Okay. So NumPy is able to work on this kind of arrays. But if you try to do the same thing with maths, so if I do print empty dot exponential a, okay. So it gives you this error, okay? Because maths does not work with vectors. It can only work with scalars. It works with scalars in this particular case. Okay, but NumPy is able to work with vectors. So if you give it a vector, this exponential, it knows that you should take the exponential of its element by element. Okay, I think I gave an answer that's too long, but the short version is you put your functions in the different modules, and then you import the different modules that you want. If from a particular module, you know which functions you want, we can just say from, so instead of saying from NumPy import star, you can import exactly the modules that you want. Okay. So for instance, I can say from my module 1, I should import, okay, so I can say from my module 1, import m cube. Okay. So in this case, I'm only importing m cube. I did not import m quad, which is in module 1. Okay. So you can import only the one that you need. You can do this also. Okay. If you do import star, it will import everything. Star is a wildcard, so it will import everything. Okay. So Timileyin, I think I answered your question, and maybe
Yes.
more than I should.
Yes, sir.
Yeah. Okay. So let's go to the next part, which is file handling, and then we'll talk a little bit about exceptions. Okay. So if you have a file, how can you read the file? Okay, this is important. So we will talk about Python way of reading the files now. And then next week when we meet, we'll be doing machine learning, and we'll talk about how people that do machine learning usually read files. There's a library called Pandas, and this is what many people use for reading files, outputting files, and it's very efficient. Okay. But now we just do the basic ones with Python. Okay, so I will introduce two methods, but they are equivalent. So the first one is we can just say my file. You have a sorry, not you create a handle. So this is what we call a handle. You can use any name for it. I can say F11. Okay. Just say handle, and the handle is the syntax is open. You've put the name of the file that you want to open. This one I already created it, so I know it's there in this directory. And then you tell it whether it's a read file, whether you just want to read from it, or whether you want to write to it, or whether you want to append to it. Append means there's something already in it, and then you want to add some things to it. Okay, so so you can do different ways. So in this case, let's just first read it. Okay, so R is for read, W is for write, and A is for append. Okay, so this is going to open this file called mylines.txt and read it. Okay, actually it's opens the file. Okay, and then I can read it in different ways. So this just opens the file. Okay, if you print F11, it will just tell you is a memory location. Okay, so or if you print, so F11 is not the file. Okay, so you see is a wrapper, the mode is R, encoding is this. So it's not the file. It's just a memory that tells you, I don't know exactly. Maybe it's a memory that tells you how to read the file, but this is not the file. Okay. Then if you want to read the file, what you do is you can read all the lines of the file. So let's call it lines. So I'll call it f11.read lines. Okay. This will read all the lines of the file. So everything will be there. And if you print lines, okay, it will print everything. So actually the file is a file that has, so let me show you the file. How do I do this? So this is the file I created it today. So this is just the file. My name is this. I'm a lecturer at this. My research is in condensed matter, and I live in Nigeria. Okay. So 4 lines. Okay. So when it reads it with this lines equals f11.read lines, because I read all the lines, okay, it will read each line into a list. This /n tells, it's just a way to say this is the end of the line. Okay. /n means end of the line, /n end of the line, /n end of the line, and it reads each one as a string in the list. Okay, so you can do this, but this will read everything. Imagine that you have a file that is, okay, do you want to read everything at once? Definitely not. Okay, so you don't want to read everything at once. So instead of reading everything at once, the other thing you can do is you can read it line by line. Okay, so I already opened it with this handle, F11. Oh, by the way, once you open it and you do stuff in it, people advise you to close it. Okay, so you should close it. Sometimes the system closes, Python closes it for you. Okay, but so you should close it. Okay, so now that I've read it, I probably should close it and just do F11. Close. Okay, so this will close it. Sorry, I don't know why didn't it print the lines first. Oh, yeah. So I closed it and I need to open it again. Okay. So what I'm going to do next is I'm going to read it. I'm going to open it, and then I'm going to read line by line, and I'm going to do some things to illustrate something. So I'm going to say for line, it doesn't have to be line. You can use I, you can use J. Just something to itemize, to go through the list for line in F11. Okay, you should do this. So you should let S be line dot. I'll tell you what I'm doing now. Okay. Okay, if you just say let S, okay, let's do the for line in F11, I'll just print the line. Okay. So it's going to read the line and it's going to print it. But when he reads the line, when he gets to the end, he reads /n, which is an extra line, and he's going to read that again. So when he does this, he's going to print the line, print an extra line, print the line, print an extra line after that. Okay. So this is what we see. So my name is Akin-Ojo. That was a /n because in the file here, okay, I went to a new line. So it's going to read that as a new line. So remember, remember when we were here, where was it? I think yeah, when we did this before I close it. Okay, when we did this, okay. I hope it worked. Sorry. Let me open this. You will see, I just want to remind us that there was a new line at the end of everything. Okay. So you see there's a new line here, /n is a new line. Then there's the next one and there's a /n. And then there's the next one, there's a /n. The last one does not have a /n because I did not put a space, a new line at the end. Okay. So when this one reads it, it's going to read exactly this. My name is Akin-Ojo, full stop. And then it's going to read a new line. Okay. So now when it prints it, it's going to print my name is Akin-Ojo. And then it's going to print a new line because of this. And then it's going to print I'm a lecturer, blah, blah. And then it's going to print a new line again. So it's just going to do that. That's why you have all these spaces after. It prints the first one, then it printed a space. The next line it printed, then a space. The next line it printed, then a new line. Okay, new line. Okay. This one after I printed this, there's no new line here. Okay. If you don't want it to print the new line, you want to strip the new line. What you can do is you can strip the new line off. So you use this strip command. You don't put anything in the argument, and it's going to use exactly nothing to strip it. Okay. So if I do this now, you see it's wrote it down without any of the spaces, any of the new line in between. So what kind of object is this line of strip? It's actually a string. Okay. For string, there are many functions that you can use with string. One is uppercase. So I can convert everything here to uppercase. So I can do upper. Okay. I'm actually combining many things in one. So what I'm doing is I'm doing S is line dot strip. Okay. And then I'm doing S2, let's call it S1. And then I'm doing S2 equals S2. So S1 is the line without the end of line. And S2 converts to uppercase. So let's print S1. Okay. And then after I will print S2. Okay. And this we do it line by line. Okay. So it doesn't do everything at once. It's for each line, it's going to do this. So first it's going to strip. So you're going to have something like this. The S2 dot upper, sorry, S1. The S2, which is S1 dot upper, it will take this one that it already stripped and it will change everything to uppercase. Okay. So if I run this, we'll have something like this, and then the next line will be the same thing, but everything is in uppercase. Okay. So you see, it ran this one, and then it ran this one, which is in uppercase. Then it ran this one, and then it ran this one, which is in uppercase. Another thing you can do is you can say from S1, let's do S3. You can say it's S1, and you can replace everywhere you see O, You can replace it by, I don't know, let's say M. Okay. So I take S1, everywhere I see O, I replace it by M, and I'm going to print it. So I'm printing, for every line, I'm printing 3 lines. Okay, so if I do this, okay. So what did he do? I think I made a mistake. Oh, yeah, this should be S3. Thank you. Okay. So the first line is your regular line. The second line, it converted it to uppercase. The third line, everywhere I saw little O, it changed it to M. Okay. And then it did the same thing for the next line. This one is the same as the first because there's no little O there. And then it is almost the same, but there's condensed matter. There's little O here. So you change it. Okay. If you like, you can convert to lowercase also. So you can do that. You can, yes, you can replace different things like that. Okay. So this is one way of doing it. Another way of doing it is instead of saying F1 is open my lines this way, you could use something else, which I'll just do now. And that's the one which is in the notebook. Okay. You can use this with open this as file, and then you can, if you like, you can read all the content. This will read all the content. If you like, you can read it one by one. Okay. Line by line. Okay. So we're going to do that and read it line by line. Okay. So instead of doing this, I'll say with okay. So we open as F11, and then I'm going to say for line in F11, and then now unfortunately I have to indent each of these ones too. Okay, so I indent each of these ones. So this is another way to do the same thing. The claim is that this one, if you use width, okay, so this one I don't need again. The claim is that if you use width, when it finishes, it's going to automatically close it for you. Okay, but you can do this with open files as F11. If you like, you can write it as file or whatever name you want. Okay? So if I do shift return, it does the same thing. Okay. Well, the claim is that this one, when it finishes, it closes the file for you, whereas the one I did before, it doesn't close the file. Okay. I don't know, one can verify that. Okay. So this is how to read the file. And how to write the file is similar. So you can open, or you open it with W as file, and then you write. Okay. And if you like, you can append also. Let's do this and append. Okay. So I'll do this, I append to the file I already have. Okay. So the file I already had before was, okay, my lines.txt. Okay, I'm going to append to it as file. File dot write hello file. Sorry, hello file. Okay, I do shift enter. Okay. It seems as if nothing happened, but one thing you will see if I go to my lines, there should be a line there now that says hello file. Let me reopen it. I think it will be there. It may not show for some reason, but I think it should be there. So let me be patient. Another way I can know whether it's there is I can repeat the same thing here and do shift enter. So you see there's this hello file that it appended to it. Okay. So there's hello file that it appended to it. And this hello file was not there before. It appended it to it. You see, yeah, so here it appended hello file to it. I should have left a space or put a new line before appending it, but it's fine. You get the idea of how to do it. Okay. So what if the file is not there? What should you do? Okay. One thing is you can try to open the file, and then if the file is not there, you can use an except and print the file not found. Okay. So one of the things is Python allows you, instead of crashing the program in errors, to use try and except. So for instance, if you have a program and a game and tell users to enter positive numbers, then if a user enters tell users to enter non-zero numbers and you are doing some division. If the user enters 0, it's going to crash your program. Okay. But you can check first that the division can be done before you now try to do anything. Okay. Let me give an example. Let's have a code that you give it any number, is going to give you the square root. Okay. So the code is code to find the square root. Okay. So let's write the code this way. So we use some of the things that we have learned before. So let's say input number because it's a float, and we're going to ask the user to say, please input positive number. Okay. And then we are going to print f the square root of the number you inputted is input number star 0.5. Okay, so this is the code, very simple. Oh, sorry, let's do this. Square equals okay. So I find the square root. The square root of input number is square root. Okay. So I'm going to run it. And the first time I run it, let's assume the user is some good obedient user. You said input positive number, it gives you 4.0. Enter, and the square root of 4.0 is 2.0. Okay. Now you get a crazy user. He doesn't listen to you. You said input positive number, or he reads too fast. He just sees input number. Okay. So he puts minus 4.0. Okay. Okay. In this case, it actually works because Python knows about complex numbers. So it actually gave you 0 plus 2j. I'm trying to think of a case in which it's not going to work and it's going to, oh yeah, let's not look for the square root. Let's look for the fourth root. Let me do minus 16.0. Oh, this still. So I think this thing is still smart, whether it's positive or not. I want a case where it doesn't work, that if you give it the thing is going to throw an exception because it can't handle it. Well, in this case, it's still because it knows about complex numbers, so it's still able to do it. And if I do just even if I do 1/3, it's still going to do it. Okay, let's do it this way. Let's input non-zero number. Okay. And all this does is to find the inverse. Okay, let's just do this. The inverse of input number. Okay. So if you're a good user, you're going to 5, and it's going to give you 0.2. If you're a disobedient user or you don't read well, you just say input number and you put 0. Okay. If you do this, you see it gives an error, so the code crashes. Okay. So if I don't want the code to crash, one of the things I can do is I can try to division, and if the division works, then I go ahead. If it does not work, I print an error message. Okay. But then it doesn't crash like this. It doesn't write yeah, it doesn't crash like this, like it did here, This one is actually a crash of your program. Okay. So you want it, what people say is that you want it to exit gracefully without crashing. So you want it to do something gracefully. So we are going to say it's going to try to do this. Okay. If this does not work, then it's going to do an except. Okay. So I will say inverse. Inverse does not exist. Okay. Then at the end, I'll print this. Okay. So if I do this, and if the person types 0, okay, you see the inverse of 0.0 does not exist. Okay. It doesn't crash like before. It tries this and it finds that this gives an error. Then it goes to the except and takes this one. Okay. If you put 5, it will have no problem. And it should just tell you the inverse of 5 is 0.2. But if the user does something wrong, like put 0, okay, and it tells you that the inverse of 0.0 does not exist. Okay. So this is a way so that instead of the code, it tells you that this does not work. Okay. It's good to use this, especially in cases where maybe there are so many options that could crash the program. And you can't think of all of those options. So you can just tell it to try it. And if it doesn't work, it will just report an error that it doesn't work. Okay. There are many variants that you can do with this, but we won't get into it now. Okay. Any questions before we go ahead? Because I'd like us to go into classes. Yeah. Any question before we go ahead? Okay. So what I want us to do next is classes. I'll tell you the way I understand classes. So classes. Actually, they call it object-oriented programming. Okay. In my view, object-oriented programming is something related to data structures and algorithms, but data structures, and is a way, in my mind, to create a new object type, to create a new type. There's a type called string, and if I define something as a string, there's something I can do with it. Okay. So instead of saying a type called string, I can say there's a class called string. Okay. And once you define something as a string, there are certain things you can do to it. If you add two strings together, it just concatenates them together. So if you add two strings, Nigeria, Abuja together, you just create one long string called Nigeria, Abuja. And okay. So strings are not the only objects you can create. You can create integers, you can create floats. How about we think about the fact that maybe you want to create your own object that is not a string, is not a float, is not an integer, but it's something else. For instance, you can create a class of students, and each student will have their name, their matric number, the courses they're taking, okay? Maybe their CGPA, you can have it, okay? And then you want to know what does it mean to add two students together? You can define that also, okay? So these are the things. So you define a new data type. Okay. So apart from string, which we know, apart from integer, which we know, apart from float, which we know, you can define your own, say student, or you can define your own, say different ones you can define. Okay. So the first example I will take is a mundane example. And then later on, we are going to take an example that can be quite useful. Okay. And that will be the example of vectors. Okay. So, oh, by the way, you should try this, a program that counts words in a text file. How many words are in a text file? You should write a program that does that. Okay. So line by line, you can count how many words are in it. You may need the split command, split. Okay. So you may need the split command. So you may need where am I writing? Yeah. You may need split command. Yeah, like when you read the line, you can say S equals line does split. Yes. If you do line dot strip, and then you split it after. Okay. Then you can count how many things are in S, and then you can count for the next one. Okay. So think of object-oriented programming and classes as a class is just a way of defining a new data type. Okay. So I'm going to just do this one, which is there, and I'm going to show you how it works. And then we create one that is more useful, and we'll see how it works. Okay. So this is just a mundane thing. Okay. So in this case, this class that has been created does not take in any arguments. Okay. So here the class sorry. Sorry, I shouldn't say it doesn't take in an argument. It takes in an argument. Okay. But the argument it takes in, you pass it through name. So first you define a class dog. So you can think of it as, so I can say my number equals, let's say it's in C, integer as an integer. Okay. So this is similar to what we are doing now. Okay. So we are going to create a class called dog. Okay. And in Python, there's always, well, it's advisable to create this constructor. This is called a constructor. This creates a particular dog. Okay, it's a constructor that is used to know how to create particular instances of dog. Okay. And later on, you'll see that you can create many dogs, just like you can create many integers or create many floating numbers. Okay. So this function is called a constructor, and it helps us to create the object that we want to create for the class. Okay. So in this case, you put two underscores, and then there's init, and then it's followed by two underscores. Okay, so those are two underscores. This self is always there. So once you are defining a class, you always put the self. Okay. And then if the class will take arguments, like this one does, you put the arguments here. It could be one argument, it could be two, it could be three. Okay. For instance, I can take the name of the dog, and I can take also the color of the dog or the kind of the dog. Okay. I can take both of them. And then you give the name that, in this case, the name that came, you give it to this, to self. Okay. The way we do that is you do it as self.name. Okay, equals the name that came. Okay. And if there are other things that you want, maybe you want the weight of the dog, you put it there also, and you can do self.weight equals weight. Okay. If you want the height of the dog also, okay, so you have to put all of them here. Okay, so there's self, which is always there, and then you have all these attributes. All these ones are called attributes of it. Okay, and then if you like, you can define an action, for instance, a function within the class. In this case, the function that is declared is this function back. But when these functions are inside the class, they are called methods. So they are called methods when they're inside the class. Called methods when in the class. It's a function, but it's called a method when it's in a class. Okay. And then this just says print this. Let's have it print something else. I'm going to say to print my height is self.weight. Let's just have you say these two things. Okay. So the next thing is I'm going to define a dog. Let's define dog one. Let's call it Rex. That's here. And I'll put the weight there. Let's call it 30 kilogram. And then the height, let's say, is 0.5 meters. Okay. So if I call the dog, so the way I call this function, so once I do this, dog one equals this, I've defined a dog called dog one. Okay. The name of the dog is Rex. The weight is 30. The height is 0.5 meters. Okay. And then I can call this function dog1.back. Okay. It's going to do exactly this thing. Okay. And it's going to say Rex says woof. My weight is, and it's going to give you the weight. Okay. So if I run this now, you see it says Rex says woof. My weight is 30. Okay. Later on, I can define another dog. Okay. So I'll use the same dog class, and let's call this Max. Okay. And let's say Max is heavier, 40 kg, and is a bit taller, 0.75. Okay. I do this, I've defined dog. Okay. You can find the type of dog. And it told you the class is in class dog. And I can also let dog two back. Okay. and it's going to say Max says roof. My weight is 40. Okay. So in the same way, just like if I declare a string, my name is okay. By defining a string, I've defined this Omololu as something in a class string. Okay. And I can look at everything that is in the class string. So I can say, I can print so one of the functions that is in, well, we'll call it methods, that's in type string, is upper, which you just learned about. So if I do this, okay, the upper function or method, which is in type class string, does this. Okay. If you want to make it lower, okay, it does this. Okay. So in the same way, you see, we use dot the name, then dot the function, and it does this. Okay. If you want to know all the methods that are in the name, I can do this, and it gives you all the method. I can swap the case, I can strip, I can split the line, I can use upper like we just did. Okay. The same way, if you want to know all the things that are in dog, say dog2, okay, you do this, and it tells you all the methods that are in it. These methods that have underscore, they are created automatically once you create this init thing. The ones we created ourselves is this function back, okay, and then these attributes are there: height, name, and the weight. So they are there. Okay? So you can do this. So you see, just like some people created the string, we now have created our own type, which we called class dog. Okay. Let's create another class for vectors. Okay. One of the things, let's say we didn't have NumPy, okay, to be able to add two vectors or multiply vectors together. Can we create our own class? Yes, we can. So we can create our own class of vectors. Okay. And the same way we do this. What should I write first? Self, okay, self, okay. And then let's make it a two-dimensional vector. X, it's going to take X and Y, okay. And then self.x is just the value of X that we put there. Self.y is just the value of Y that we put there. Okay. So this is going to define a vector for us, okay. Now, let's create methods for the vector, okay. The first method I want us to create is a method that tells us how to print the vector. Okay. So it turns out that there's this special methods that you can use. So I'll just put the self in it, and sorry, and I'm going to return how do I want to write it? Let's use this to denote a vector, and then I'm going to put self.x, okay, and I'm going to put self.y, okay. Okay, so I'm going to define this vector, and I'm going to this class. So this is a class vector. So let me define a vector v1 to be vector. It will take two variables, x and y. So let's say 3 and 2.5. Okay. Okay. And then I can print v1. Okay. And then it prints 3 and 2.5. Why did you use these angular brackets? Because when I define this string, okay, this string is a special class. Okay, it tells you how to return a string of vector. No, it tells you how to return vector as a string. Okay, so it's up to you how you want it to look. So you can use this. If I like, I could have put this way and put this as this angular bracket. So if I do this, it just tells you how should I report vector as a string. Okay? This is what this string function does. Okay? So then, so if I define this as a vector, if I print this now, you see one end is square, the other is this angular bracket, because this is what I defined in this string thing. Okay. Let's put it back as this. Okay. The other thing I want to do is I want to be able to add two vectors. So there's something which is add. So, okay. So there'll be one vector self, there'll be another vector. Let's call it the other vector. And I'm going to return vector, a vector that has two components. When you give me self and other, and I add them together, I'm going to add x component of self with x component of other, and that'll be my x component. And then I'm going to add y component of self, y component of other. Okay. That'll be this. So when I do this, if I do create v1 and v2, I can add them together, and it's just going to add component by component. Okay. The other one you can do is you can subtract. Let me cheat. I mean cheat by copy and paste, because then it takes less time. Okay. The other one you can do is you can subtract. So this is sub. Okay. So if there'll be one vector, the self, which is always there, and then there'll be the other one, so I can subtract. Okay. So you can do this. Okay. What of multiply? Okay. How would I know what to do with multiply? Okay, so I have to tell you this. So you can always do a Google search. And if you do a Google search for operator overloading, is this? Yeah, so it tells you the different special functions that you can use. Okay, so init initializes the attributes of the objects. This string returns a string representation of the object. This one returns the length of the object. This adds two objects. This calls objects of the class like a normal function. Okay. There's a list that I was looking for. Yeah, so there's sub, this is subtraction. There's mul, ouch, sorry. Okay. There's mul, which is multiplication. There's pow, which is power. There's true division, there's floor division. Floor division gives you like integer division. There's mod, there's L shift, right shift, and all of this. So I'm going to use mul for multiplication. And if you want, you can use power and this. Okay, so you can make a Google search for it, so you'll find all the ones. The first time I did it, my guess was that it would be mult, but then M-U-L-T, but it's not mult. Okay, so it's M-U-L. Okay, so what I wanted to do is to multiply component by component. Yeah, okay, so to just multiply component by component. So I have this, okay, and then I can define the vector v1. Let's do something simple, 3, 2. And I can define the vector v2. 1, 3. Then I can print v1 plus v2. I can print v1 minus v2. And we can print v1 star v2. If you like, you can say v3 is v1 plus v2. and V4 is V1 minus V2. Let's call it VP for V plus and Vn for V minus. And then we can add both of them together. Print VP plus Vn. Or before then, find the type of VP because we didn't define VP as a vector or something. Okay, but because of what we have here, we made it a vector here. Okay, then it's going to be a vector. Okay, so let's run all of this and see what we want. Okay. So the first one is V1 plus V2. So this is giving us 4 and 5, 4,5. So let's see. Yeah, 4,5. And then V1 minus V2 is 2, minus 1. And it gives us exactly this. Okay. And then V1 star V2 will be 3,6 because it should multiply it element by element. So 3,6. And then, sorry, I should do this as print the type. So I printed VP plus VM. VP is V1 plus V2, VM is V1 minus V2. So if you add both of them, you should get 2V1. So 2V1 is 6,4. So it's exactly what you get. But let's see what type VP is. It's class vector. Okay. So this is how you create vectors. Sorry, how you create classes and how you use classes. So V1 is an object of type vector. V2 is also an object of type vector. Other things you can do, so if you look here, it talks about inheritance. Inheritance just means that you can create another class, okay, that uses some or all the attributes of the other one. Actually, if you create, so here they already created a dog, and then they created a class animal. No, sorry. Here they created a class animal. Then they created a class, okay, cat, which inherits the properties of class animal. So everything that is in animal will be in cat, okay? And then one of the things they did was to override a function in animal. That was this speak in animal. If you did not define this function, cat will, when you say cat dot speak, it will, this pass means it does nothing, okay? It will do nothing, okay? But we wrote a function that overrides the previous one. So now the cat will meow, okay? Actually, this is an interesting one. So because you can okay, this is mundane. So we say, how come they, in this case, they do not have the init thing? Okay. There are quite some soft programs. If you don't initialize if you don't create, put your constructor, it will put a default one for you. So I think this is what happens in Python too. Okay. So let's do this. So pass means do nothing. Okay. So when you, in this class, animal, okay. So if I create, okay, so I'll do this. If I say, what do I want to say? I want to say m equals animal. Okay. Okay. If I say m dot speak, it's not going to say anything. So it doesn't say anything because I said pass. Okay. Okay. Let's make it say something. Okay. Let's make it say print I am an animal. Okay, so we do this. So M is animal, and then if I say it should speak, it just says I am an animal. Okay, okay. So cat, I can have cat also. Cat inherits all the things from an animal. Okay, let's be more sophisticated. Let's make sure it speaks. And it moves. Moves, we just say print. I like to crawl. So class animal has self, sorry, has moves. Okay. Class cat does not have moves. But class cat inherits everything from class animal. Okay. So now let's create a cat. Okay. I don't know. Okay. Let's call it Shakespeare. Cat. Okay. So now I'm going to tell Shakespeare to speak. You see, it meowed because the class speak in cat overrode the speak in animal. Although cat inherited all the properties of animal, but when you define this method, it overrides the one that are already in the other one. Okay. And then what if you try to let Shakespeare move? Okay. Oh, sorry, moves. And he says, I like to crawl. Because in cats, there's nothing that replaces moves. Okay. And let's have another one for dog. And the one for dog, we can call it, okay, the dog will bark. Okay. And if you do it, we can create legs. And then we let legs speak. And it says woof. Okay. But when legs moves, it crawls also. Okay. Because we didn't give something else to override the crawl. If you want something to override, I don't know, the crawl, we can create one that is a bird, and then because a bird has to fly. So you can do this, bird. Let's say it doesn't speak, but it moves. As print, I like to move. I like to fly. Okay. So you can just create one that you call parrot, and it's a bird. Okay. And you can say parrot dot moves, and they tell you I like to fly. Okay. Yeah, so I think this is the basic thing about this is basic Python. You can read a file, you can put your file, you can write to a file. The other things I think that are important, like how to call the OS from within the Python. You can call the operating system within the Python. So this is possible also. Okay. So I don't know if anybody has questions. There are many other things that you can do. Oh yeah, I wanted to do something with this. Um, for this, you have to import. Okay. Yeah. Um, yeah. Let's do this one because I think this one is useful. Um, actually, in this case, I wanted to. Okay. So there are many things you can do with Python. Okay. Um, which I think we'll do some of them. So let's look at this. So there was a time I wanted to get the data from Nigeria Stock Exchange. Well, of course, I don't want to be going there and getting the data. And it's every day I want to download all this the stock and the percentage change. Okay, say at 12 noon. So there's a way you can make a request um, to a website and be able to go there. And okay. So let's do this one and see. Um, uh, so this has an error. Um, or valid URL. Okay. Um, so let's do this. So I need to put all the okay. I don't know exactly why it's giving me this. Um, okay, so I don't know exactly why it's giving me this. Um, let me think a little bit more about this. And then also I'll show you the one I wrote that is able to yeah, I'll show you the one I wrote that's able to scan the New York, the Nigerian Stock Exchange. So I'm still here, but okay. Um, okay, let me share my screen with you. Okay, so I import request just like this thing tells me. And then there's this beautiful soup that is good for you to install. Okay. And it helps you to sparse, no, not sparse, to pass the files. Okay. And then have a URL. So this URL, you can go exactly to this. It has a list. And then I want to get everything that is in the list. Go to get it. Okay. Using this request.get URL. And then beautiful soup helps me to pass it. Okay. And then at the end, it returns the results for me. Okay. So when I run this, okay, don't worry about what is below after exit. When I run this, it's going to give me all the Python script. So it's going to give me a list of all the tickers. Okay. So it's going online, yeah. So it gives you a list of all there are like 340 or so of them I can count. So, and it tells you the price, the current price. I think all these FGs are maybe treasury bonds or something. It tells you all the prices. Okay. ABB 20265 is 100 naira, 0% change today. Ace Corp 23 naira 80 kobo, minus 10, minus 0.1% change. Many of them are 0% change. That shows you that the stock exchange is not active. Cadbury, the price today is 26.60 and it's increased by 2.4%. So if you had invested in Cadbury day before yesterday, today you have increased your wealth by 2.4%. Okay, but this I was able to do with this commands import request, and then from BS4 import beautiful soup, and then I have this URL. This you can go to this website, so I can go there and show you how the website is. You actually have to be able to read the website to. Okay, so there's this website. It's going to give you the list, but I don't want to go there and be clicking and downloading everything. Okay, so then I'm able to use Python to just go there. Okay, so this is it. So if you go here, all the, you see this ABTS that I had was there, 8.79, there's no change. Okay, and this is COP, that was change 0.1. If you go down, you see Cadbury 24.2, that was an increase 2.4%. Okay, so it goes and you see there are many pages, so it gets all the 148 entries, 1 to 25 or 148 pages. It goes there, it gets everything, and it gets it for me, and I don't have to visit the website. Okay, I had to visit the website once to know what to do, to know how the data is arranged and everything. After that, then I don't have to do that. Okay, so let me see, import request and my URL. So let me see what's the problem with this one? URL is this. Response is request.get URL. Response dot get URL. Yeah. I don't know if I need to do this. Okay. Oh, let me just print response, not response.json. Okay. It just gives me a response like this. Okay, let me use this one that I used before. Okay. It gives me the same thing. And then yeah, you guess this. Oh yeah, then I use beautiful soap to pass it. Beautiful soup to pass it. So let's do that. I'll use beautiful soup to pass it. I don't know if I install beautiful soup on this or not, so I can't say for sure. And then I can print soup. So it's probably telling me I did not install. Yeah, beautiful soup is not installed. It's not defined. Okay, the easiest way to install it is to do pip install. And I think it's beautiful soup. I think. If it's not, then I have to look at how to install beautiful soup. So it's just going to install it and then you'll be able to, yeah. So it's downloading it. So it downloaded it. I did not. Oh, I need to do beautiful soup 4. Okay. Let's do it. So I install beautiful soup. Okay, so it's installed. Now I can try to run this. You see, one of the things is I read the error, which error is telling me. Okay, so you do that. Now it still gives me an error. Beautiful soup is not installed. Um, so maybe I should do. Um, oh, I need to import it. Sorry. Oh, BS4 import. Actually, I think I should have installed BS4. All right. Okay. So let's see if it works. Installed. Let me try to do it. Okay. Okay. So yes, so it went there and tried to get. Yeah, I went to the website. It tried to get all the information. Okay. So the information. This is the information that it got. The information you need is here. You just have to find a way to pass it and get exactly the price. So all the prices are there. Then you have to be able to do some passing to get the information that you need. So it does work. Okay. Um, okay. So I think I want to, oh, yeah. These two are straightforward things. Okay. If you want to create a list, um, say that is like 0, 0, 4, and on like that, you can just use this list comprehension. It will just expand it. Okay. So for instance, if I want to get 1 over x for 1 to 10, okay, I can use this list comprehension and be able to do it. Okay. Basically, it just means that it expands the list. Okay, it expands the list. Squares is x squared for x in range 10. Then it's going to put in squares. Squares will now be a list. The first thing in the list will be 0. The next will be 1 squared. The next will be 2 squared, and on like that. So if you do this, and let's print squares. The squares will be a list, and it's 0, 1, 4, 9, 16. Okay, because what this does is it does x squared for each of those ones, and then you put everything in this kind of a list. Okay. You can do inverse also. Let's do inverse. Well, inverse, I'll start with 1. 1 over x. For x in range, it starts with 1 up to 11. Okay. Oh, sorry. Then the next thing I want to print it. So you see, it's printing the inverse of all the numbers from 1 up to, but not including 11. Okay. The other thing is some functions are very simple and you don't have to write a def. So for instance, if I want to square, I don't have to do this def my square x return x squared. You don't have to do this. Okay. You can use the lambda function. And that is what was in the next thing here. Okay. You can just use the lambda function and instead of defining my square. So let me do that. So it's my square 2. Okay. And it's lambda. I need to get the syntax right. Okay. So it's lambda and then x. And then you put a variable. And then what should you do with the variable? The variable should you put there. What should you do with it? It should square it. Okay. So I define this my square 2. And then I can do my square 2. Oh, sorry. I messed up. Let's put an A here. And let's put 3 by 0. And it's give you exactly 9. So I don't have to do def something. And even if you want to do magnitude of 2 numbers, magnitude of 2 numbers, I think you can do something like lambda x, y, and you can do let's do it as x minus y, and then we can find the square root of it. Let's just do this. Okay. So you can also print mark 2. Let's put 1 here and 3 here. Okay. So the magnitude should be just 2. Okay, so it prints exactly 2 for us. And if you change it to 3, 1, it prints exactly 2 for you. Okay, so this is a short way to quickly define simple functions. You don't have to do def and all this. You can quickly define this way. Okay, so I want to stop here. If you have questions, we can take it. And then next week, when we start, we will start with machine learning. One of the things is I want you to do an exercise. To write a code that guesses that chooses a number, and the user needs to guess the number. So of course the code will give hints. It will say something like higher if the chosen number is higher than the guessed number. So to say higher, if the chosen number is less than the guess number, and it will say lower is smaller than the guess number. Okay. You can give the user a number of tries, and then at the end you have to give the user 5 tries. And then you can score the person 1 if you guess it, 0 if he does not get it. And then 2 people can play the game 5 times or 6 times, and then they see who is able to guess the number. You will need a random number generator. How to use Python's random number generator. So this is straightforward. You can look for it online and be able to get the information. Okay. Thank you very much to everybody. And if you don't have any questions, we can close now. And then we'll meet again on Monday for our Start Machine Learning.
Hello, sir. I don't know
Yes,
if we can get this Python file. This one that will work on today because I skipped some of.
Oh, okay, yeah. So I will send this to everybody. I'll along
The
with the ones
codings.
for the code
Sir?
I'll send to you. I'll
Okay,
send
sir.
it to you. I'll send to everybody along with the ones for Monday and Wednesday
Okay, sir.
and the videos. Okay. Okay. Thank you very much, everybody. Have a good weekend.